Hello everyone, and welcome to the third video in the derivatives and integrals series. So this video is going to be sort of concerning the derivative of sine x. As established in the other video, I said it was just cosine x, and I sort of just let it at that. But now that we know chain rule and product rule and stuff like that, we can get to the sort of why, which no one really teaches you why this is the case without maybe using like the standard definition for derivatives, which I don't really want to get into. But anyway, it'll be helpful to know the following identity here. This is Euler's identity. Cosine x plus I sine x is equal to e to the ix, where I is the imaginary unit, the square root of -1. Okay? Now, this is sort of the same thing as saying the imaginary part of e to the ix is equal to sine x. So why is this helpful? Well, because we can rewrite this as the derivative of the imaginary part of e to the ix. We can now take the imaginary out and just take the imaginary of the entire thing. Right, instead of the derivative of the imaginary part, we can take the imaginary part of the derivative. Those are equal to each other. Same thing for integrals. This is a very, very useful trick. Sorry, I meant to write e to the ix. Great. Now we do know how to deal with something like this. This is again chain rule, right? So we know the derivative of e to the ix is just gonna be e to the ix times the derivative of ix, which is just I, right? Now we only want the imaginary part, so I'm going to expand this again. We're going to get the imaginary part of cosine x plus I sine x, and then all this is times I. And you'll recall that I squared is -1. So this is what we are left with. Great. Now, what is the imaginary part? Well, this has the imaginary unit, this doesn't. So I think it's really obvious. The imaginary part is just cosine x. By the way, if you don't understand this imaginary notation, the imaginary part of a plus bi is equal to b, and the real part of a plus bi is equal to a. Just keep that in mind. Which is why the derivative of sine x is cosine x. Okay, if you do know Taylor series, that's another way to derive this. But anyway, I thought this was just a really cool sort of way to understand why the derivative of sine x is cosine x. And there you go.